We've been learning about exponential equations for a while, so now we're going to use Desmos to actually write the equation. So this is actually called exponential regression. We did linear regression back when we were doing linear equations, and we had to use the y equals mx plus b, that famous equation. Well, here we're using the famous equation for exponential functions. Y equals a times b to the x. We are going to follow these steps that we have on the front. So I'm going to go through them real quick, and then we're going to go through them on an actual problem. So just like with linear regression, you click the plus and add a table. You put in the x and y values into that table. You click the little magnifying glass to see all the points, and it should look like an exponential. It should have that curve to it. Then you put in y1 squiggly a times b to the x1. You have to click the little box next to log mode. Make sure you check that. So draw this little box with a check mark, and you'll see it whenever you put this equation in. And then it'll give us our a and our b, and we'll write our equation to the hundredths place, which means 2 decimal places. Okay, so let's look at first example. Example 1. So this is actually what your screen will look at like whenever you do it correctly. So we're going to follow the steps. So let me pull up Desmos and hit refresh. So I get a new Desmos page. I want both of these at the same time. Okay, so let's follow the steps. Push the plus. Add a table. We're going to put those in. So let's start with the x's. See how it says x1? So 0, 1, 2, 3, 4. Next, put in your y's. 1178, 990, 865, 776, 693. Okay, I cannot see my points. So that's why this little magnifying glass, circle this. What it does, it zooms to the points. Zoom fit. It makes it where you can actually see what the points are and how the graph looks. So click it. Now you can see it kind of looks like a straight line, but it's a decay. So we know it's exponential decay. Now we're going to come up with the equation. So go to line 2 and type in y1 squiggly ab shift 6 to get that exponent, and then x1. Whenever you put your ones in, it automatically goes to the subscript. Don't forget log mode. So I'm circling that on my notes. Don't forget. So we're going to use the information that they give us from this to write our equation. So it gives us A and B. So circle those. So now we can write the function. Remember, it's y equals a times b to the x. So y equals A. This, remember how we said 2 decimal places? So 1,148.68, parentheses, that's already 2 decimal places. 0. Oh, I want to do 2 decimal places. That's 0.877. So I'm going to have to do some rounding there. So you look at the first 2 decimal places. You look at the third one to determine if you're going to keep that 7 as a 7 or make it 0.88. 5 or more, raise the score. 4 or less, let it rest. So this is going to be 0.88. So remember, 5 or more, you're going to raise that number up. 4 or less, you're just going to keep it the exact same. So that's my B value, 0.88 raised to the x. So that's my equation. Now it says use the equation to predict the y value when x is 11. So anytime we predict, we're going to use the function, plug in the value that they've given us, which is x. So we're going to do f of 11 equals, that means we're substituting in 11 for x. And we can use Desmos for this too. All right, so go to Desmos and just type this in. I'm only going to type in the right-hand side. F of 11 is just the name of the function. So right here, I'm going to put this in there. And we're going to round this one to the nearest hundredths place also. So that's 2 decimal places. 281.519. So remember, for 2 decimal places, we would look, we want these 2, but this 9 is going to tell us whether the 1 stays a 1 or goes up to a 2. It's going to go up to a 2. Good. Okay, so we're done with that one. Let's go to the next problem. Example 2, the following data represents the amount of money an investor has in an investment account each year for 8 years. Determine the average annual rate of return on the investment. Write the exponential regression equation. Okay, so for investments, we have compound interest. So that's why it's called exponential. So let's go to our Desmos and plug this in. So usually with Desmos, what you can do is you can hit this little refresh button. And then you can go ahead and put that into the table. So go ahead and put these into the table, our data values. And we're going to write the equation. And you do have to do all of them. You can't just skip. You have to give them all of the data points that you have. No, do not put the comma. Whenever you do data like this and you're dealing with these big numbers, I want you to double check your numbers to make sure that you put them in correctly and put them with the right year. So year since 2008, 20,000, 21, 225, 22, 357, 23, 620, 25, 88, 26, 482, 27, 978, 29, 612. And click the magnifying glass so you can see these data values. There we go. So it almost looks like a straight line. That's going to be exponential. Huh? Did you do the magnifying glass? Oh, no. Like, it almost looks like a straight line. It kind of does. But if you zoom out, it looks more exponential. All right, so let's go here. Put in our function, regression function, y1 squiggly ab raised to the x1. You can zoom out and look at that exponential function. Looks pretty cool. Oh, don't forget to click log mode. That's going to change the equation. Did you click log mode? Okay, good. I almost forgot. All right, so we're going to write our equation now. So y equals 20,018 1.0. What are we going to do for that? 057 06. Yep. Raised to the x. If it doesn't say what to round to, put all the numbers down. Okay, predict the amount of the money the investor will have after 15 years. So we're going to do f of 15. $20,018, 1.06 raised to the 15. Let's put this in, and I'm going to show you something else. Oh, 15. Whoops. Thanks. 15. But let's say we use that full B value. I'm going to do 1.0575 to the 15. Okay, so what I did was I used the hundreds place and then I used the full amount. Whenever you use the entire amount, then you're actually getting closer to the exact. So if it doesn't say to round, just use the full amount. So I'm going to do this. Or 20,018, 1.0575 to the 15. This is more of the exact amount. If we're talking about money, we want 2 decimal places. So we're going to go 83. So the other one, it was 47,973. So it's a little off than the actual. So if you want the actual amount, you'll use this full amount and also this full amount. Don't round on your A and B. But of course, if it's multiple choice, you're looking for the closest to the answer. All right, you need to go ahead and glue this in.